Welcome to solving modulus equations with the tx-CG100. In this video, we will demonstrate how to perform analysis of a graphed modulus function, including finding roots, intersections, and vertices, together with solutions found numerically using solve_n. To start, press Home and select Graph and Table. The display shows the Function tab, where we can enter the modulus function in Y1. Press Catalog and then select Numeric Calc. The function can be entered using the absolute value template. Enter the function using the dedicated x_θ_t_y key for the variable. Confirm the entry with OK or Execute to store the function ready for drawing. To view the Graph tab, either tab right or select Draw Graph. The View window pop-up opens by default. Select Draw from the pop-up with OK or use the shortcut. To solve this equation, where the function is equal to 0, we can analyze the sketch. Press Tools to open the pop-up and select Graph Solve by scrolling or using the shortcut. Select Root with OK or the shortcut. The leftmost root, -1, is indicated by the cursor and the coordinate values are shown. To show the truncated decimal coordinates of the root, press OK. Then scroll to move the cursor between roots. Press OK again to label the upper root with the coordinates. End the root analysis with back to show the pinned points. If required to find the vertex of this modulus function, the solution to algebraic manipulation can be confirmed by analysis. The vertex clearly lies within the horizontal scale and so can be found. However, it may be useful to press Subtract to zoom out, so that it is displayed on the graph. Notice that the root labels are no longer shown after zooming. Press Tools and select Graph Solve as before. Then select Minimum Value. The vertex is found with the coordinate values shown. Pressing OK shows the coordinates, and press back to end the analysis. It is also possible to analyze functions numerically. From Home, press Calculate and Catalog. From the pop-up, select Function Analysis and scroll or use the shortcut to select Function Minimum. At this point, we need to enter the function, which we could do using the absolute value template seen earlier. As the function has already been stored in Graph and Table, however, it is possible to recall it using graph notation. Press Variable to open the pop-up. This menu allows you to recall variables, functions, lists, and so forth that have already been stored. Select Function to view all the functions stored in Graph and Table. This displays the modulus function we entered earlier as Y1. Confirm the choice of function. This enters the graph notation in the template and not the function itself. Then enter some bounds for the analysis where the minimum may lie. And execute. The x and y coordinate values are then displayed in a list. To solve equations where modulus functions are equated to other values or functions, it can help algebraic understanding to draw the graph. To solve this equation graphically, press Home and return to Graph and Table. Enter the right-hand side function as written using the fraction template and confirm the entry. Then press Right tab to open the View window pop-up and draw. Both functions are drawn and it is clear that there are two intersections and so two solutions to this equation. As before, press Tools to analyze, and then Graph Solve. This time, select Intersection. The left intersection is found first and can be labelled with OK. Scroll to find the right-hand intersection, which can also be labelled. To view the pinned intersection points, press Back to end the analysis. The same equation can also be approached numerically if only the x values are required. From Home, return to Calculate. Press Catalog and select Function Analysis as before. To find the intersections, select Solve Equation, Solve n. The template opens and the equation can now be entered. For more information on how to use this functionality effectively, please see our other videos. To enter the left-hand side, use the same input as for entering in graph and table. Press Catalog and then select Numeric Calc and Absolute Value. Then enter the function. Press the teal-coloured Shift key and then open parentheses for the equal sign. The right-hand side function can now be entered using the fraction template. Calculate and close the warning. The two x values of the intercepts are displayed, in this case, as exact fractions in a list. If the x values were not simple fractions, it could be useful to extract individual values from the solve-n solutions. To do this, press Catalog. Either scroll or use the shortcut to navigate to Statistics. Select List to input the list command. Then press Alpha and Format to recall answer. Open square brackets with Shift and 4 to recall -half, enter its position in the list, in this case position 1. Close the brackets, although it is not necessary, and confirm. This recalls the value and it is now available to store as a variable or perform calculations with. We hope that you have found this video useful. If so, please do check out our other resources on the Casio Education UK website and YouTube.